So in order to make the most of your statistical testing and make sure that you're not wasting your own time, make sure that you understand why these tests are being used and chosen, it's important that we go over levels of measurement. So even if you think you already know all this and you're the smartest person ever, I beg of you to just stick around for a couple minutes. Let's go over all of this together as a refresher, if nothing else, just to make sure everybody's on the same page, and then I will set you free and you can do your own thing. But I still see people in graduate school, in my classes who really struggle to qualify their variables because they just never really had this broken down for them. So we'll start with qualitative, we'll move on to quantitative in our next video. If we back this all the way up, all the way back to basic statistics, qualitative versus quantitative, you might be tempted to say, oh, words versus numbers. But I would like to direct your attention to this particular phrase here, with no amount of difference. So it's fine and dandy if you want to think of your qualitative variable as words, but it's also very important that you note that there is no measurable amount of difference between your qualitative variables. That's a very important distinction. And your quantitative variables are a range of values, they're numbers. So we'll talk about that later though. So a type of qualitative variable is a nominal variable. When I see the word nominal, my brain automatically says name. A name is a good example of a nominal variable. But a nominal variable is just a label or a category that has no intrinsic value. It can't be ranked. So my name's not better than your name. We can't say that one's bigger than the other one. So another good example of this would be gender. So we have male, female, non-binary, other. These aren't ranked. There's no natural rank here. A dichotomous variable is a type of nominal variable. When I see a dichotomous variable and we talk about it, my brain automatically just says binary, because a dichotomous variable only has two options. So a good example of this would be answers to a yes or no question. Apparently. A yes or no question. So there's only two options. That's a dichotomous variable. Pretty quick and easy, right? So our last guy here, ordinal. When I see ordinal, I think order. Pretty straightforward, right? It's very exciting. An ordinal variable, it throws us back to this with no amount in our differences. So to break that down a little further, an example of an ordinal variable might be a pain scale from 1 to 10. See how that gets kind of hairy if you're saying that qualitative variables are only numbers? So you have some numbers here. They're part of a pain scale, but there's no set value. There's no set amount of whatever, something we can measure between 1 and 2 and 2 and 3, etc., all the way down the pain scale. We know if someone says that they have a level 8 pain, that it's much worse than a level 1 pain or a level 3, but it's less than a level 10. So we can kind of get a feel for a natural rank, a natural order in these numbers, but there's nothing that we can measure between the scale. So another example, just to drive it home, would be Likert scale. If you're not familiar, the Likert scale is it's a rank between 1 and 5. It ranges from any take on strongly disagree to strongly agree, or anything like that, or dislike a lot to like a lot. So we know that a 1 on that scale, dislike a lot, would, if you're asking someone for a preference, is much different than if someone were to say 5, I like it a lot. But there's nothing that we can measure between those things, so because it's a subjective opinion, right? So that would be an example of an ordinal variable. Next, we're going to move on to quantitative variables. That's very important, so stick around for our next video.